Good day. We are going to present our joint work, Too Many Meetings, Scheduling Rules for Team Coordination, and we'd like to thank the Service Science Best Cluster Paper Competition organizers for selecting our work as among the finalists. My name is Guillaume Roels from INSEAD.
And my name is Charles Corbett from UCLA. So this work was partly inspired by some very nice ethnographic work that was done by Leslie Parlow, who studied experiments around time management in a software engineering firm. So what you see here is an example of a typical day in the life of a software engineer. But when you look closely, what you'll see is that most of the day consists of one interruption after the other. And only at the very end of the day was there a solid block of time when the engineer was able to get some serious individual work done. And I think that's something that many of us recognize because almost by definition, if we're meeting, we can't be individually productive and working on our own tasks. Now, surprisingly, though, you might ask, well, how often should we be meeting? There's really not very much known about that. There's lots and lots of blogs and things floating around, but in the end, the advice often comes down to something like, it depends. And there's really not much guidance on what is the optimal frequency with which we should meet. And that's exactly the question that we try to start answering in this paper.
So to answer this question, we look at a stylized game theoretic model. So just to give you a glimpse of how the model works, so suppose that Charles and I are working on different pieces of the same code. We can work independently, but once in a while we need to coordinate. And so we look at short time periods, maybe half days. So in the first time period, Charles is very productive, but I've encountered an issue. I'm not sure of what I'm doing, so I'm a bit less productive. And so as time progresses, we might still encounter some issues. And at some point, I become so unproductive that I take the liberty to interrupt Charles. And we are having a meeting in which we resolve all our issues, making us fully productive in the following time. Again, we might face some other issues later in the future. So we are going to keep track of the stock of accumulated issues that each of us encounters. And of course, that has going to have an impact on our productivity. The horizon is infinite and time is discounted by a discount factor. So early completion is better. So in this model, there is an inherent trade-off between production and coordination.
So you could imagine lots of different kinds of policies to determine how often to meet. And a kind of stupid policy would just be to either always meet or never meet. That's not too interesting. But a very common policy in practice would be just to set a fixed schedule. Like we meet once a week, regardless of whether people want to meet or not. What might seem more appealing is to have a policy that depends on whether workers actually want to meet. So one option could be to say, if anybody wants to meet, we'll meet. Right? We call that preemptive coordination here. It's a bit like an open door policy. The opposite would be to say, the default is, right, all doors are closed, everybody's working, and we only meet if everybody agrees to meet, and we'll call that preemptive production. A third option would be to say, we'll just point to somebody and say, you decide whether or not we meet, and that's a more hierarchical approach. Now, with any one of these approaches, there's a risk that one individual person could essentially derail progress for the entire team by wanting to meet too often or too rarely. So we could build in some time safeguards around that. So for instance, you could have an open door policy, but you could say, once we've had a meeting, for the first 2 days after that meeting, everybody closes the door and works, and then we go back to the open door policy. And what the paper does is try to characterize which of these policies is optimal and how well they perform under various circumstances.
And so we do characterize these prescriptions in terms of worker homogeneity and team size. So the key insight is whenever the team size is small and workers are quite homogeneous, a fluid approach works quite well. So whenever it's worker driven, so preemptive coordination, preemptive production, or hierarchical structure, which one really depends on the context, but it remains quite fluid. But as the team size becomes larger, or when workers become more heterogeneous, you want to build more rigid controls into the policy, such as the time-based controls that Charles just mentioned. And the idea is to avoid the squeaky wheel phenomenon, so to avoid being derailed by one particular worker who always wants to work or never wants to work. Whenever the team size is intermediate, you might use these time-based controls or delegate the decision rights to one worker. So a hierarchical structure would do quite well. And then finally, and surprisingly, we find that when the team becomes quite large, let's say maybe 10 workers, a fixed interval policy, which is quite common, is nearly optimal. And again, it's because it alleviates the squeaky wheel phenomenon. So this is, in a nutshell, the essence of our paper, and we very much hope that there would be a lot of follow-up work. Thank you.
Thank you.